have your review for your final exam. So we're going to start quickly. It's going to take a lot to go through, but appreciate your patience and your willingness to work hard and finish strong. I know you're going to do great. Question number 1 says, tell whether or not the relation is a function. Well, you want to look at all the points, and in order for a relation to be a function, I got to make sure this is going to work, you want the x's cannot be repeated. It's fine for the y's to be repeated. What you want to look for is in your relation, you want to make sure there's no place where the x's are repeated. So when I'm looking here, I have a 1 and a 2 and a 6 and an 8 and 11. So my answer would be yes, this is a function. I'm going to pause this for a second. My pen's not working. All right, question number 2. Given that f of x equals x squared minus 4x plus 3, find f of negative 2. So what you're going to do here is everywhere there's an x, you're going to plug in a negative 2. And if you're wondering about where do people make mistakes here, it's not putting parentheses around a negative when you're squaring it, because negative 2 squared is 4. But if you type in your calculator, if you just type in negative 2 squared, it's going to tell you negative 4. So what you've got to remember is you've got to remember to put negative 2 in parentheses and square it. And that way it's negative 2 that's being squared and not just the 2 that's being squared. So it's going to be 4. Minus 4 times minus 2 would be plus 8. And then plus 3. So 4 plus 8 is 12 plus 3. My answer number 2 would be 15. Number 3. Find g of 5 plus h. So what I want to do here is everywhere there's an x, I'm going to put a 5 plus h. So it's 5 times 5 plus h cubed. So let's expand that a little bit. And this is where it'll help. And that kind of looks like s, but it's a 5. So I'm going to multiply the first 2. That'd be 25 plus 5h. And I'll multiply the last 2. So to multiply the last 2, I'd have to do 5 times 5. Then I have to do the outers. So that'd be plus 5h. And the inners, that'd be plus 5h. And the last ones, that'd be plus h squared. Now for this, I didn't have to FOIL. I just had to distribute. So 5 times 5 is 25. And 5 times h is 5h. So I'm going to simplify it a little more before I distribute again. I can combine 5h and 5h to make it 10h here in the middle. Okay, so now I've got to distribute 25 times everything, and then 5h times everything. Okay, 25 times 25 is 625, plus 25 times 10h would be 250h. And then 25 times h squared would be 25h squared. And then 5h times everything would be 125h plus 50h squared plus 5h cubed. So simplify my answer. I'm going to write it in descending powers of the variable. 5h cubed is first. And then I've got a 50h squared and a 25h squared. So that'd be plus 75h squared. And then I've got a 250h and a 125h. That'd be plus 375h. And then finally my constant term, which is plus 625. Whoa. 5h cubed plus 75h squared plus 375h plus 625. And there you go. You can read a little bit better before I circled it. All right, problem number 4. Find the domain and the range of the function represented in the graph. The domain is your x's, so you want to see where does it go on the left to where it goes on the right. So if I'm looking on my x's, I have values between negative pi and positive 2 pi looking on the graph. So because negative pi has a point here, 2 pi has a point here, and there's a point everywhere in between it. So I want to put brackets because it can touch those points, negative pi to 2 pi. For my range, I want to do my y values. So if you look on the y-axis, it goes from, I'm going to go from bottom to top, negative 3, and there's a dot, so that indicates that it can be that point. If there had been an open circle instead of a closed circle, then I would have had to indicate that with a parentheses and not a bracket. But from negative 3, there's points all the way to positive 3. And I want to close that off. So negative 3 to positive 3 is the range. That's your y's. And then negative pi to 2 pi is my domain. All right, number 5. Now we're finding equations of lines. So what you have to remember is y equals mx plus b. You need 2 things to know the equation of a line. You need to know the slope, which they give me, so I'm a little ahead there, and then I need to know the y-intercept, which is b. So to find b, I'm going to plug in this point that's on the line for x and y. So negative 1 equals negative 2 ninths times x times 2 plus b. And then we'll solve for b. So negative 1 equals negative 4 ninths plus b. Add 4 ninths to both sides. If you have negative 1 and you add 4 ninths, you get 5 ninths. You could do it on your calculator if you need to. Negative 1 plus 4 ninths. Get an answer. Push math, enter to change it to a fraction. So it's negative 5 ninths. And I'm keeping it as a fraction because the slope is written as a fraction. Chances are your answers, if they're multiple choice, will also be fractions. So my equation will be y equals negative 2 ninths x. So this should be a negative minus 5 ninths. So there's your equation of your line. Next several problems have to do equations of lines, so you're going to want to remember this y equals mx plus b. So now I don't know the slope. I do know the y-intercept because this is 0, negative 2. So this is going to be b right here. Because if it's the point 0, negative 2, think about where that's at. That's here. That's on the y-axis. So that kind of helps me. So I've got this point that's going through negative 5, negative 9, and 0, negative 2, and I've got to find the equation of this line. So I've got to find the slope. So it's going to be y2 minus y1 over x2 minus x1. So negative 2 minus negative 9 is 7. 0 minus negative 5 is 5. So there's my slope. And my y-intercept is negative 2. So my equation is y equals 7/5 x minus 2. Now, if I didn't have the y-intercept, once I found the slope, I'd need to go back and do the problem like number 5, where I know the slope and I know a point on the line. Use either of these points to find your y-intercept. All right, number 7. I need to go through this point, so I'm going to use these for my x and y, and I need to be perpendicular to this line. Well, if it's going to be perpendicular to this line, I've got to figure out the slope of this line. So to do that, I solve for y. So I'm going to move 8x to the other side and divide everything by 5. So negative 8/5 x minus 9, because 45 divided by 5 is 9. So this is my slope. This is my y-intercept of this particular line. All I need, if it's perpendicular, is I need this slope. So I'm going to use the point negative 5, negative 1, but for my slope, if it's perpendicular, you take the slope of this line and you turn it over and change the sign. So your slope is going to need to be a positive 5/8. So use this for x and y. Negative 1 equals m, which is going to be 5/8, times x, which is negative 5, plus b. Negative 1 equals negative 25/8 plus b. Add 25/8, which would be 17/8 equals b, I think. Let me check myself. Negative 1 plus 25/8, math, enter. 17/8. All right, so the equation of the line will be perpendicular to this, y equals 5/8 x, and then the y-intercept is 17/8 plus 17/8. All right, let's see if we can do a parallel one right quick. Through 4, negative 3, parallel to the line that we're given. So the first thing I want to do is solve for y in that line. So I move the 7x over and I divide by 9. Doesn't really matter what I get other than this slope right here is 7/9. So since this line is going to be parallel, I want to use x is 4, y is negative 3, and I'm going to use 7/9 for my slope. So negative 3 equals 7/9 times 4 plus b. Negative 3 equals 28/9 plus b. So take negative 3 and subtract 28/9. And I know I go really quick on these problems. I hope that if you're having trouble that you'll go back and pause them and review, and you can send me questions, whatever. I don't want to spend hours with your review, and if you're getting things, then you can move on. So this y-intercept is going to be negative 55/9. So b will equal negative 55/9. So the equation here will be y equals 7/9 x minus 55/9. All right, I'm going to pause this right here and pick up with the next problem.